This is John Black, Superchemist. This is just a disclaimer to let you know that this video is not intended to be imitated. No parts of it should not be copied or done by you or anybody. It's just for educational and maybe entertainment purposes to watch. That's it. I don't condone anyone repeating anything in the video. Alright, I'm going to try to make some ethene today. My first couple videos, or not first couple, but in the beginning there was, I made propene from isopropyl alcohol. And I'm going to make it the same way I did there with aluminum oxide as the dehydrator. It's just basically a catalyst. You know what I mean? It doesn't get used up, theoretically. You can see what you're doing here. Here's your alcohol, right? You got your hydrogens, a couple there, and your alcohol group. Here's your double bond, and you still got your couple of hydrogens. But look at the difference. You got two hydrogens, two hydrogens, two hydrogens, two hydrogens. You can see what's in red. Those are the things that come off. Now what you notice, look at this OH. Look how far away it is from the other bonds. This is a long bond. It's like dangling out there. But anyways, we're going to delta T. We're going to add some heat. And I did my molar weights, or molar mass. The ones that had grams, I divided by density so I can get milliliters per mole. This one is a gas. That's how many grams is in a mole. But as we know, any gas is close to an ideal gas, and an ideal gas has this many liters per mole. So that means if you have 1 mole here, then you got 22.4 liters, right? Now I wanted to take 1/10 of everything. That gives me 2.24, 2 1/4 liters of gas. That's at least controllable. So I took everything by 1/10, or I just moved the decimal over 1, basically. 2.8, 28, see? And that's how I figured out what I'm going to put in there. I'm going to put this much alcohol, this time ethanol instead of rubbing alcohol, vodka. Well, actually, it's anhydrous. And I'm going to get that much out. Starts out right here. I got my ethanol in there. Yeah. And then up here, right? I got my catalyst, that aluminum oxide, right? Goes up the trail, right? And you get a balloon there. So I can see what's going on, like how much gas is, you know what I mean? How much pressure is in there. And it goes into that same dealio with the graduated cylinder. It's already filled up with water. There's barely any air in there, a little bit though. Okay, you can see the flame. Yeah. It's right above that catalyst. About 144. I think it's 250 is the when it starts being hot enough. It's almost there. Alright, here's my setup. It's basically like a distillation. I got my alcohol in there. Comes up here. Out there. I got some catalyst in there, see there? And it just comes out to this. You can see it just comes out to the open. I'm going to catch it on fire like a lighter. Some of it is going to be liquid. But you'll tell because when you see a spurt, that's usually liquid trying to force its way out. Nice steady flow of flame, that's when it's just gas. On the left there where you got the stopper, you can see up here, this is a dead end port right here coming up. This first one, you can see there's two coming out of there. One on the left is a dead port. The one on the right leads, see how it leads to the other test tube, and it has sodium bromide inside there. Sodium bromide salt, aqueous, meaning it's in water. Now I can take, and also in this left test tube, you got sodium bromide on the right. On the left, you got some calcium hypochlorite. Now I'm going to take this dead port off. Took that off. I'm going to shove some hydrochloric acid down there with this pipette. And I'm going to block it back up with this. Boy, I don't know if you can see that on camera, but it turned red as soon as it went in there. Green is still there though. I guess I didn't put enough hypochlorite in there. It's not producing any more chlorine. I'll put some more hypochlorite in there and some more acid, set it up. You can see it's a lot more red now. You just replacing one halogen for the other, like when you do with metal. One's a more active halogen, one's a more active metal. See that right on top? If you need to see it bubbling through or not. I'll just let that finish up. You can see my point. This is the last thing. I got some ethanol again in here, but I put some chunked up glass in there. I don't have any cotton or anything, but usually I'd put cotton or something in there. I don't have any, and I don't have a car right now. There's my dehydrator, the aluminum oxide. It feeds out to here to an empty container. I don't know if you can see the container. I know you can see the stopper. But the empty container is because some ethanol is coming out, you know what I mean, liquid ethanol. This will catch it, you know what I mean. It'll come down here and condense, and only the propene can come, or only the ethene can come out this way to the next test tube, which has that bromine water in it, okay. And bromine water, if this goes into that, it will make a halohydrin, okay. It'll decolorize that bromine. And, you know, not just people like, normal, everyday people, but I've read many, not just a couple, many books that make this mistake. I'm talking like, even in my, it's, the name of the book is Advanced something or another, and in the thing, a lot of people think that when you put a double bond into, like, say, bromine, that you are making a dibromide, right? No, you do not make a dibromide, only if it's not in water. If it's in water, you're going to make a halohydrin. If it's not in water, say you put it in, I can't remember what they put it in, maybe DCM or something like that. They put it in there. Now there's no water to attack, so you can't get the hydrogen part. You can only get the halo. And you get two halo. You get two halogens then. Um, but in textbooks, they always say aqueous, put your double bond to test it, put it in some aqueous bromine, and then you will make a dibromide. You do not make a dibromide if you have aqueous bromide. Now there's an outlet on that last test tube, so it won't fill up. There's two holes, one hole for the tubing and another hole for an escape, so it doesn't build up too much pressure. Oh, there goes the bubbles finally. Jeez. Now that red should be getting lighter and lighter as I do it. Well, first I got to get rid of the air. That's probably the air. It's gone through. And about now it should be getting some propene, I would guess. Keep in mind, propene is not soluble in water. When I get done, I'm going to have to shake it up. Take that cap off and shake it. It's not going to all react. Going down now. Does look like it's getting lighter, but like I said, most of it's just escaping. It's like I'm heating shit up too much here. You can see it filling up with ethanol right now. I shouldn't have put so much bromine in there, man. Hopefully I got more alcohol in there enough to do this. I figure making very little propene, you know what I'm saying? Because the gas takes up so much volume that you can't really make that much. That's the whole problem here. But I'm going to shake it up. Well, it's not clear enough. But I'll tell you why. It's because I put too much bromine in there, man. I put too much of it, whatever. Because look at the difference, though. It did take some of the bromine away. Look at that. I mean, that's almost clear. Compared. See, there's the liquid that came over. Should have put that in an ice bath. At the very end, there was a little bit coming over of the alcohol. But, I just wanted to show you the 3 different colors. Although on camera, these 2 kind of look like the same color. But this is actually red, this is orange, and this is yellow. And this was my original bromine. I took half of it and put it into here. And when I bubbled stuff through it, turned it orange. But I put too much bromine in there, too much bromine water, you know what I mean? So I took half of it out and I put half in here. And it was orange, and now it turned yellow when we added some more or whatever. Now I kept putting more gas in there. I should have figured it out my stoichiometry, but I didn't. But you get the gist. It is, doing something there. It's changing the color. Obviously, it's taking the bromine out. Bromine's red. There's probably some chlorine in there. I always remember, science is great.